The purpose of this video is to help us to solve more complex absolute value equations. Give you a quick reminder of some of the things that we had seen earlier. First of all, we've learned that absolute value equations might have two solutions to them, and here's an example of one. And we had a few different ways we could think about that, but ultimately we decided that the number inside the absolute value could be 5 or negative 5. Both of those cases, if you had a 5 inside and took the absolute value, you'd get 5. If you had a negative 5 inside, you would take the absolute value and get 5 also. So two solutions to one looks like that. One solution is a little unusual. That is when your absolute value statement on one side is equal to 0, because then the only number that could be inside to have that work is 0 itself. So x equals 0 is the one and only solution. We also saw ones that there's possibly no solutions to. And here was an example that we had seen before, where if you're telling me that the distance from 0 to a certain number that I'm thinking of is -4, I'd say, no, that's not true. Every distance ever is a positive one, so absolute values need to be positive. So another thing that came up in the last video, which I think is really going to become important now, is that we don't distribute over addition and subtraction. So we had seen this example that absolute value of 5 minus 8 is not going to be handled by taking the absolute value of 5 and the absolute value of -8. We don't distribute absolute value over addition and subtraction. And that may not have crossed your mind, but I think today, or in this video, you might see more students lean that way. But this was what we actually needed to handle at that time, was to think about that number a little bit better. 5 minus 8, that's a weird way to say it. How about instead just tell me it's -3 and the absolute value of -3 is 3. So that's some pretty good evidence that you couldn't have distributed the absolute value. Because here, when you look at something along these lines, I don't know how many moves you have in your toolbox for solving this equation. If I need to try to get at x, and the only thing we've really worked with so far is inverse operations, then we're probably at a loss. We don't have an inverse operation for absolute value. So when that kind of first hesitation pops up, then I start seeing a lot of students make a lot of guesses. So this might be a case where even if you weren't tempted to distribute absolute value earlier, you might be tempted to do something like, hey, let's write the left-hand side as 2x plus 8 and just run with it. But that's not the correct idea. So let's instead talk about what does need to occur. First of all, we should look at this and we say, this really feels a lot like one of these ones where there's two solutions. Because, big picture, if you step back and look at it, the absolute value of something in this problem is equal to 14. There's some expression, this time it's not just x anymore, but there's some expression inside the absolute value. And what we know is that the absolute value of that bit, that amount, is equal to 14. So I would like to use logic and to say, so you're telling me that this 2x minus 8, whatever that is, after I absolute value it, the result turns out to be 14? Well, then that tells me that the stuff that you're talking about, 2x minus 8, could be -14. Or it could be positive 14. So if we don't have an inverse operation for undoing absolute value, what I describe this step as is using logic to rewrite an absolute value equation as two equations, neither of which has absolute value in it. And what that does is it puts you in a great spot, because we know how to solve both of these equations extremely well. So if we can get in the habit of looking at an absolute value equation and looking at that absolute value equation and saying, how can I rewrite that in the two cases that are out there? How can I rewrite that as two separate equations that don't have absolute value in it? Because then your skills could kick in. And we could find out that if x was -3 and x was 11, that this equation would work out. What's happening is if x is -3, then the stuff inside takes on the value of -14. So ultimately the absolute value does equal 14. Or if x equals 11, then the stuff inside takes on the value of 14. And the absolute value of 14 equals 14. So, in review, let's get in the habit of splitting absolute value equations into two separate equations. If you're having a hard time with the logic, let's take a look at this thing graphically. Because what we did previously was we looked at absolute value as a statement about distance. And it was a distance from 0. But in this case, the distance from 0 is not being described on x. It's being described on 2x minus 8. That equation can be thought of as saying the distance of 2x minus 8 from 0 is 14. So I think that means then that 2x minus 8, as I had said earlier, must either be 14 or -14. So this is a visualization of where this logic comes from, just in case you like that better. And it's very unlikely that this is going to be someone's favorite approach right now, but I thought I would show it because it might be a tool I use later on. and that's using the algebraic definition. So if you remember the algebraic definition, the idea was this: the absolute value of x, we said, could either be replaced by x if we knew the stuff inside was positive, or the opposite of x if we knew the stuff inside was negative. Well, now the stuff inside is more complicated than just x. So if we say the stuff inside 2x minus 8, it's potentially that could be a negative number. And if so, when I rewrite this without the absolute value, I would like to write the opposite of what's inside in the place of the absolute value. Absolute value is sometimes equal to the opposite of what's inside. That would look like this. That's the more complicated one. Simpler one is when the stuff inside is positive, because when the stuff inside is positive, the absolute value doesn't really have any effect. So that side of that thought process, we could make the 2x minus 8 the entire expression. So if we solve those two equations, it would take you on like a little bit of a different method over here, but you would still get those same two answers. So as I mentioned, I don't think that this is people's favorite way to do it typically as you're learning it. Instead, it would be something like this. How could I have ever taken the absolute value and gotten 14? Well, that could have been because the stuff inside was negative 14 or the stuff inside was positive 14. So let's take a look at, continue to take a look at this kind of more complicated situations. And in this case, I really need you to notice something here. This looks a lot like one of these ones where we're going to attack it now. We got to think about two separate equations, and let's think about the positive and negative implications. But we need to slow down a little bit. First, I need you to notice that this equation actually doesn't explicitly tell you anything about absolute value. It's not saying the absolute value of x minus 1 is something. It's saying 5 plus the absolute value of x minus 1 is equal to something. So I think what we should do is we should try to turn this equation into an equivalent equation that looks more like what we just handled. In other words, this 5, we should make it disappear. And you can do that because this is an equation and we've got balanced inverse operations as a tool. So we can choose to subtract 5 from both sides. And that will leave you, not with x minus 1 yet. Unfortunately, the absolute value is still there. But it'll leave you with an equation looking more like the last one, where your logic can kick in. Or you can envision x minus 1 in two different spots on a number line. Or if you're really adventurous, you could do the algebraic approach. But I think right now I would just say, I know from this equation that either x minus 1 is 2, and that's why its absolute value is 2, or maybe x minus 1 is negative 2, and that's why its absolute value is 2. So it feels like one of these situations where there's two answers, and there's two answers. One comes from the stuff inside being negative 2, one comes from the stuff inside being positive 2, and then we're in complete control. And we did get our two answers. Just a couple more examples to kind of let you know what to be on your toes about. Here's an equation, and it's starting to look more and more complicated, but if we've got the strategy of let's kind of like peel the layers off of the absolute value, and we'll get a good absolute value statement, we can do that if we notice that this equation didn't tell us really what the absolute value was. So we'll start kind of chipping away at the absolute value expression. This outermost layer, we're going to get rid of that using an inverse operation, a nice balanced way. You get to here. And now this is probably a relatively new move. This looks probably a lot to someone's eye like a place where distribution could kick in. And it might have even looked like that up above here. But it's not a good habit to get into, to start distributing things into absolute value. Absolute value just doesn't work like most of the math does that we're used to. So instead of finding a way to combine the 2 with the x minus 1, we can continue to use inverse operations, and we're going to make this layer go away. This says 2 times the absolute value of x minus 1 is equal to negative 16. Well, how about we divide both sides by 2? If you divide both sides by 2, the canceling happens. You find out what the absolute value of x minus 1 is, and you start to be able to realize, you know what, this doesn't feel like something that has answers at all. Because if the absolute value is equal to a negative 8, that doesn't sound like something we're able to do, even though the inside is more complicated than just x. When you stand back and look at it, the absolute value cannot be negative, so that has no solutions. Just one last example then. And it looks innocent enough because of this positive value over here, but I need you to remember this equation is right now not telling us anything about absolute value. It's telling us some convoluted story about absolute value, and the result is 8. So it could be, there's a lot of things that could happen here. So let's instead, we'll make this term disappear. I hope you're already predicting how I'm going to do that. And these will cancel, and the right side turns into a 28. And then next, I'm going to make this term, so this factor disappear. This times negative 2 disappear, and I'll do it by dividing. And then here we are again at this spot where the absolute value equaling a negative just doesn't seem to make sense to me. There are no answers to that equation. So that's another one where there's no solutions. So hopefully, now that you've looked at 4 examples of these things, you are kind of primed to find answers, equations that have 2 solutions, no solutions. I want to remind you that 1 solution is out there, but then also that you've got this idea of how you can use your inverse operations to get to an absolute value equation. And then from the first 2 examples, at that point, you can split the absolute value equation so there's no absolute values left and your old skills can take over.